What is up, Joe Gamers? Today we'll be doing finding max and min again, but this time we're domains. Our domains are equations like equation g of x, or it can be a circle, which is also an equation because there's no exact equation for a square. I mean, you can do it piecewise, but you know what I mean. But there's like one specific equation you can get. You get a circle, and there are other different things called restrictions, which are basically domains that are that are just equations. So this is called Lagrange multipliers. And they're basically, if I were to draw it out, look on a 2D contour map, say, let's see, drew some examples before somewhere. Oh yeah, okay. Say your function, this is your function f. I need to do this in a different color. Let's do blue. Let's do this, and it gets. Let's say this is your function's contour map. And it's like kind of circular, but like I'm gonna try finishing that, but yeah, like something like that. Um, so this is f, and you can say this is like k, f equals k, and k equals 6 here, k equals 5 here, k equals 4, so on. And then we're gonna have another contour map of a different function and call it g. This is g, and this function kind of does this. Oh shit. Does this with your function? And assume I was a perfect artist and it was actually the same line, like they both touch each other and they have the same tangent line. This is what is important. We're trying to find the greatest intersection, perfect intersection that have the same tangent lines. They both have the same tangent line. And the biggest difference is their gradients. I said a gradient of a function is the point that is first of all perpendicular to the tangent line, and second, it is the greatest point of ascent. So say your gradient line is this way for the f of x, and it's gonna point perpendicular to the tangent of it, like this. See how I'm trying to draw it as perpendicular as possible. So this is what F's gradient line would look like. This is what G's gradient line would look like. Oops. Let me see this real quick. Yeah. Alright, hold on. Oops. It would be probably pointing away from it'd be pointing the opposite way of the gradient lines of F. That's what I'm basically trying to pick right now. And how is it supposed to find maximums under a restraint or domain? Which, based on the principle that, like I showed earlier, that say this is, so this is G, and this is F, and since they both have the same tangent line right here, and this tangent line is their maximums because of how it curves. Because you're not gonna, yeah, and then, but the distinction here, and this is why you can find maximum minimums, because we found a point where their tangent lines are the same and their maximums, right? So their gradient vector points one way and the other points the other. It's not to say that G gradient G is exactly negative of gradient F, but rather it's some multiplier, because G can actually be a lot longer than F. It's just in a different direction, but they're still parallel. In fact, I think maybe that G's gradient vector. I mean, technically this shouldn't be possible, but technically, if they are parallel, it could point this way. But obviously, from this graph, it should be pointing. I mean, it just depends on the graph, whatever it is pointing. But just know, here is the main important thing. The gradient of f is equal to something called the Lagrange multiplier times the gradient g. As shown, they are parallel, and it's just some multiplier that distincts the two vectors. So let me see through this book real quick. Yeah, so alright, let me just say for multiple constraints, let's say let's see how much time we got. For let's say two functions, or I mean a 3D function. This is gonna be bad to draw. Actually, I'm gonna not try to draw this. It's actually pretty hard to draw. Let's just say if f is a 3-variable function x, y, and z, then and if there was two constraints on it, it would then be equal to the Lagrange multiplier of g that is also three functions and 3-variable function plus another Lagrange multiplier signaled by mu, and this function would be this, like that. So that's how you would do it. That's that, but simplified this form, because we need to get f of x equals 0 and all that equals 0, right? So to simplify, f equals Lagrange gradient g, we just write as f of x equals gx, and we say that's equation 1. Equation 2 is fy equals Lagrange gy, and so on. And then then at the last equation n, we'd just write the function of g, and g has to equal some constant,
When sweet tarts
like
dare to
x
combine
squared
sweet and
plus
tart,
y
they thought,
squared
why
equals
stop
1
there?
can be
Why
an
not
example
create
of
other
g.
exciting and unexpected combinations, like rainbows and ropes,
So
or
let's do
fruity
some
and gummy,
examples.
or chewy
Alright,
and more chewy? That's why they created fun and tasty treats, like
so there's
sweet
some
tarts
pretty
twisted rainbow
complex
ropes and gummy
problems with
halos.
this.
When you dare to
Try to
combine, it's
get
sure to
an
blow your
easy
mind. Sweet
question,
tarts,
not
dare to
easy, but
combine. Tap the banner or visit
uh,
sweettartscandy.com
let me
to
just
shop
find some
now.
questions.
Sometimes you need a little help keeping your home running smoothly. That's where the Home Depot Home Services
You know
comes
what,
in.
I'll do a
Our local
2D,
licensed and insured experts can handle
a
all
3
your home
variable one.
maintenance needs, and you can rest easy
Alright,
knowing that all work is backed by the Home Depot. For
okay,
license
so we
information,
got
visit
the function
homedepot.com/license numbers.
f x y z equal to x plus y plus z with the constraints x squared plus z squared equals 2, and then a second constraint, and let's just call this g. Second constraint x plus y equals 1, and let's call this h. So first of all, let's get f of x, which would be 1, and in fact they would all be equal 1. And we get, to find the Lagrange multipliers, we do g Lagrange plus h mu, and we get 1 equals, and let's get the partial derivative to x with g, that should be 2x. 2x plus, and this would just be 1, so mu, that's equation 1. Equation 2 would be 1 equals this partial derivative to y, and this would be 0, so there's nothing there. And for mu, there would be 1, so mu. And then we'd have equation 3, 1 equals, with respect to z, this would be 1. Alright, so that's just plus, well, there's nothing, no z here, so that's just how it is, I guess. Wait, oops, it's supposed to be squared, my bad. So that means, alright, yeah, that's fine. Okay, so, because that's squared, that's 2z actually. And that's plus nothing, so let me just rewrite that real quick. Alright. So, and then our fourth equation would be g, which is x squared plus z squared equals 2. And fifth equation would be x plus y equals 1. So straight off the bat, we already got that mu equals 1. And because of that, we can actually sub it into equation 1. So equation 2 equals equation 1. And, or sub in, and then we just get 1 plus mu 2x plus, equals 1, and that would just be 0 equals 2x mu. And then you'd get the answers x equals 0, and whatever this is equals 0. I think that's lambda. So, with this, we can connect it to some equations, like this one. If we plug in x equals 0 to this into 5, or no, into 4, we get z squared plus 0 equals 2, so z equals plus minus square root 2. And then for that would also mean y equals 1. And yeah, that's basically all. Let me just see real quick though. Alright, yeah, so okay. If you try plugging in lambda for any x, like, for this one, it would just make 0 equals 1, so you can't do that. And the other one, this u equals 1 is just the same thing, so yeah. These are the only answers you can get, which are z equals plus or minus 2, y equals 1, x equals 0. So the function should be 0, 0, 1, and plus or minus square root 2. And from this, we can plug in, and we would get 1 plus or minus square root 2. And based off this, oh yeah, I forgot. We still have to, we're finding the maximum first and minimum. Since these are all equal to 1 and cannot be equal to 0, we do not, let's call it, we don't consider these. We only consider the answer here. And because 1 plus something is greater than 1 minus that thing, then that should mean 1 plus square root 2 is a max, absolute max, and 1 minus square root 2 is absolute min. Alright, I think we can do one more that actually shows a better way, or not better, but like, you know what, yeah, just a better understanding of it. Let's see what I was doing here. What the hell am I doing here? Yeah, I'm probably not gonna do that one. Hold on.
Wherever.
Well, let's
In
do
fact,
this quick
hundreds of
problem.
vehicles
Not
from
really
top
quick,
local
but you
dealers
know,
all in one
another
place.
two
You can also
variable
apply for
one
financing, add
or
optional
three
protection
variable one
products,
then.
and determine your trade-in value,
Y
all with
and
transparent
z
pricing. Then once you've made your purchase, head to
equals,
the dealer
where
to
am
test
I?
drive, wrap up, and drive home happy. Go to
It's equal
Amazon.com/autos to start
to
car shopping today. Now get back
yz
to your busy
plus
life. Amazon Autos, car shopping that clicks.
Hey Bellingham, Alan Stone is coming for one
xy,
night only. Don't miss out on the Resilient
and the
Project's first
constraints
annual benefit show
are
featuring Alan Stone.
xy
Thursday, November
equals
13th
1
at the Mount
and
Baker
y
Theater.
squared
Experience an
plus
unforgettable night of
z
music and
squared
impact.
equals
100% of
1.
proceeds directly support the youth and families we serve.
So,
Sign
yeah,
up now to get your tickets today and be part of the impact.
impact. Alright, get let's get that derivative. So f of fx equals just y, fy equals z plus x, and fz equals y. So if we set these equal to 0, we get y equals 0, or z equals negative x. And so if we plug, since we can't really solve for anything right now, just put it in the function x, 0, negative x, and we just get 0. F of... Yeah, I think that's just it. Can't really find anything from this, so... I mean, let's just try not to consider these. Skippity toilet. Alright, so... Like I said earlier, I don't know where I was, kind of on a YouTube break, hold on. Y equals 0. This does not satisfy this constraint, that's why we do not consider these partials. Anyways, hold on. Actually, I don't even know why I'm even getting the partials setting it to 0 for Lagrange. Yeah, I don't know what I'm doing here. Hold on. Actually, yeah, so just check those partials just in case if they do agree, so... But right now we're checking endpoints, so yeah, the answer is probably gonna be within those endpoints. So earlier we got the partials. I don't know why I deleted them. Oh, I guess I don't have them anymore. Well, let's just go on with it. So f of x is just y equals y lambda plus 2y mu. Wait, isn't... Oh wait, no, oops. It's just no x here. Alright. And then next one is y, and then you get z plus x equals 2y mu. Wait, no. What am I doing? That'd be x mu plus 2y mu. That's lambda, my bad. And then y again, this is 1, 2, and y equals 2z mu for 3. And I'm not gonna write 4 and 5. Okay, so first of all, look at this. Y minus y mu equals 0, so y equals 0 or mu equals 0. But the thing is, like I said earlier, y cannot be equal 0, so we are ignoring this case. So, because it equals 0, we can plug it into here. Actually, let me see. If we just put it here, we can have z plus x equals 2y mu. And let's see. Wait, no, I'm so dumb. What the hell? This should be mu equals 1. So z plus, hold on, what am I doing? Actually, nah. Oh my god. So, we're gonna equate 1 and 3 because they're both y equals, and we get y mu this equals 2z mu, and then let me see here. Alright, so skip toilet. No, apparently. How am I gonna do this real quick? Oh, okay. So, if you plug in 1 for lambda, you get y equals 2z mu. And if we equate that to 2, we get z plus x equals x plus 2 times 2z mu times mu, and that's 4z mu squared, right? Yeah. And then the x's cancel out, and then we're left with fz mu squared minus z equals 0.
Every ounce of dirt, sweat, and gears, they're all jammed
And
inside
then,
can of
wait.
NOS energy. High performance energy
No, we don't
drinks
need to do
designed
that.
to boost your horsepower
I mean, you
and
can
help
do
you
that, and we
fuel
get
your passion.
z
In
equals
original zero sugar
0.
GT grape and Sonic sour flavors.
And then,
Energy. Get after it. Tap or click the banner to buy now.
yeah, we can get
Hay
z
personas que
equals
saben que
0,
pueden ahorrar cientos en seguro
or
de auto si se fijan primero con Allstate. Por
4
ejemplo, sabes que
mu
debes fijarte que tienes el
squared
tanque lleno de
minus
gasolina
1,
antes de manejar por el desierto.
and
¿Estás
that would
vacío?
just be
¿En
equal
serio?
to
Quizás pueda caminar.
mu
Así es,
equals
fijarse es una
plus
buena
or
idea. Así que
minus
fíjate
square
primero con
root
Allstate y
1
obtén una
half.
cotización que podría ahorrarte cientos.
Quizás no.
Estás en
Huh.
buenas manos con Allstate.
But then you realize
California, aplicante
z
asigna.
cannot
Tarifa
equal
incluso
0
tiene
because
beneficios.
y equals 2z mu, and y, if z was 0, then y would be 0, and we can't have that. So the only solution is mu equals plus or minus 1 half, square root 1 half. So if you, let me see, where can I find something? Oh, okay. Downloading. Freemasons. Where did I get that answer from? That's so weird. Well, if mu equals plus or minus 1/2, and then we put that into here, we get 2 plus or minus square root 1/2. Wait, what am I doing? No, oh my, so dumb. Plus or minus 1/2. And then y would equal 2 times, plus or minus 2 times 1/2 z. So y equals plus or minus z. And then x would, based off this equation, x would have to be the x would have to be the oh my god, am I trolling right now? Hold on. So with y equals plus or minus z, we can plug that into h right here, and then we get y squared plus y squared regardless of plus or minus equals 1. So y should equal plus or minus square root 1/2 square rooted. And then, so first off, z equaling plus, so plus z would equal this, and minus z would also equal plus or minus 1/2. Yes, yes. Yes, yes. What am I doing with the answer? What the hell? Alright, here's the thing. Okay. So, when in relationship to z and minus z, y and z can be either plus or minus from each other. But, or they can be plus or minus minus plus plus. But for y, for x, x is, well, since x, y equals 1, then that means x equals minus plus, because it's plus or minus square root, and then it'd be square root 2, like that. Hachini. Actually, what? No. What am I doing? No, it's plus or minus. Oh, okay. So, this plus or minus has to be the same plus or minus as y, but this plus or minus does not have to be the same as z. You know what I'm saying? So either way though. Alright, so to fill this constraint, x has to equal the same sign as y, so 1 over y, but y is equal to plus or minus z. So do you understand it now? So when we put it into f as plus or minus square root 2, plus or minus square root 2 over 2, and then I don't even know how to put plus or minus square root 2 over 2. I don't know how I'm gonna put this, but Either way though, f, so f and x, this term, you can just plug in 1 for it. So yz plus 1, because of this constraint, right? So yz plus 1, now we don't even need to matter about this. So the way to get the greatest number would for both of these to be positive, and the way to get the negative number is if they were opposite of each other, or the lowest number. No, actually, no, if they were both negative, that's how you get the lowest number. So we have either 1 minus 1/2 or 1 plus 1/2. That's equal to 1/2 as your min, and your max is 3/2. Actually, what am I saying? No, they have to be opposites to be minus. The hell? Yeah. So same sign will get you the max. Opposite signs will get you the min. There you have it. If xy was not equal to y or some else, then it'd be a lot harder to. Actually, no. I mean, if it was like x divided by y, I guess it'd be a little bit different, but because of these constraints, it's a lot more easy to find the max and min right there.